Good day, students. Welcome to chemistry lab. Welcome to chemistry class SS2. Your chemistry teacher, Mrs. Nneto, N.A. Today we are going to look into the topic that says, the topic water. Our topic for today is water. Objectives. By the end of the lesson, the students should be able to give sources of water, identify atoms which water is composed, differentiate between hard water and soft water, explain why water is a universal solvent, give the unusual properties, physical and chemical properties of water. Water is one of the most common substances known. It is a universal solvent because almost all substances dissolve in it. Sources of water. There are two main sources of water. 1. Natural water. 2. Treated water. We are going to go into natural water. The natural water includes rainwater, spring water, well water, river water, lake water, and sea water. Note: rainwater is the purest form of water which formed as a result of condensation of water vapor in the atmosphere. Spring water is another form of natural water which contains a considerable amount of mineral salt and also very little suspended impurities like dust and bacteria. It's a good source of drinking water. Another source of water is well water. It's a stagnant water that contains a lot of clay and other mineral salts and dead organisms. Before a well water will be used as drinking water, it should be filtered. Lake water, river water, and sea water contain a lot of dissolved air, mineral salts, bacteria, and organic remains. Treated water. Example of treated water is distilled water, pipe-borne water, and chlorinated water, which is normally used in the swimming pools. Distilled water is one of the chemical pure water. It is prepared by condensing steam using liebig condenser. Still, distilled water is used in the laboratory for preparing reagents. The treatment of water to make it suitable for us for use can also be done in the following ways. 1. The untreated water from the lake, river, or sea is first passed through large settling tank, where chemicals such as potash alum or sodium aluminate tray are added to cause coagulation to form big particles of dirt which settled down rapidly. 2. Then the water is passed through filter bed to remove the remaining particles. There is then treated with chlorine, with chemicals such as chlorine to kill the germs. Number 3. Iodine and fluorine can be added as food supplements to prevent goiter and tooth decay, respectively. Finally, treated water is clean and free from germs and stored in a reservoir and ready for distribution. Also, calcium hydroxide is added to improve taste for the water. The process is as follows: sedimentation, coagulation, filtration, chlorination, pH measurement, and distribution. Types of water. We have two types of water. We have hard water, we have soft water. When we talk about hard water, we said that hard water is one which does not form lather easily with soap because it contains a lot of dissolved salts such as calcium tetraoxosulphate 6, magnesium tetraoxosulphate 6, and calcium hydrogen trioxocarbonate 4. Types of hard water. There are two types of hard water. We have temporary hardness and permanent hardness. Temporary hardness. This is the type of hardness that we easily removed by boiling. It is caused by the presence of calcium hydrogen trioxocarbonate 4. Temporary hardness is caused by the presence of calcium hydrogen trioxocarbonate 4. How do we remove temporary hardness? 1. By boiling. On heating calcium hydrogen trioxocarbonate 4. On heating, calcium hydrogen trioxocarbonate 4 decompose to form calcium trioxocarbonate 4, which is insoluble, which brings out calcium ions from the solution as a precipitate. Equation for the reaction. The composition of calcium hydrogen trioxocarbonate 4 will give us insoluble calcium trioxocarbonate 4, water, and carbon 4 oxide. Another way by which we can remove temporary hardness is by addition of calculated amount of slaked lime. The slaked lime is calcium hydroxide. Equation for the reaction. Calcium hydrogen trioxocarbonate 4, when react with slaked lime, will give us insoluble calcium trioxocarbonate 4 and water. Another way is use of washing soda. Our washing soda is sodium trioxocarbonate 4. Sodium trioxocarbonate 4. When you add sodium trioxocarbonate 4 in water that contains temporary hardness, it will give us insoluble calcium trioxocarbonate 4 and sodium hydrogen trioxocarbonate 4. Permanent hardness is the type of hardness that can not be easily removed by boiling, but by use of chemicals, and is caused by the presence of calcium and magnesium ions, which is in form of tetraoxosulphate 6 and chloride. Example of salts that causes permanent hardness: calcium tetraoxosulphate 6, magnesium tetraoxosulphate 6, calcium chloride, etc. These are the salts that cause permanent hardness. Removal of permanent hardness. Addition of washing soda. Permanent hardness can be removed by addition of washing soda. Our washing soda is sodium trioxocarbonate 4. When you add sodium trioxocarbonate 4 and water that contains calcium tetraoxosulphate 6, calcium trioxocarbonate 4 will be precipitated out, and sodium tetraoxosulphate 6. From the reaction, calcium and magnesium ions are precipitated out from its solution. So what will remain in the water will be sodium tetraoxosulphate 6. Another one is addition of caustic soda. Addition of caustic soda. Addition of caustic soda remove calcium and magnesium ion as the insoluble calcium magnesium hydroxide. Example: remember that our caustic soda is sodium hydroxide. Sodium hydroxide is the caustic soda. So when you add sodium hydroxide in water that contains calcium tetraoxosulphate 6, calcium hydroxide will be precipitated out, which will be insoluble. Another one is by distillation. By distillation. This is used to remove both types of hardness, because all the ions are left behind when the vapor distilled over. Number 4, ion exchange method, or you call it permuting. An ion exchange resin is an insoluble complex compound which has sodium ions attached to its surface. Sodium aluminate trioxosulphate 4, called sodium zeolite. Hard water is passed through an ion exchange resin. Example, sodium aluminate silicate, tetraoxosulphate 6. The sodium ion will go into the solution, then calcium and magnesium ions, which is not wanted, will take their place in the complex salt. See the equation below for the reaction. We move over to advantages of hard water. Advantages of hard water. Hard water tastes better than soft water because of dissolved salts. Therefore, it's suitable for use in the beer brewer industry. Number 2, because of presence of calcium salts in hard water, it helps animals to build strong bones and teeth. Number 3, hard water helps animals like snail, crabs to make their shells. Number 4, it can pass through lead pipe because it does not dissolve lead. Number 5, when calcium hydrogen trioxocarbonate 4 decomposes, it produces pin calcium trioxocarbonate 3, which is used in making cement and quicklime. Disadvantages of hard water. A lot of soap is wasted when washing with hard water because it forms scum with soap. Hard water causes fluorine of kettle and boilers. It cannot be used in dyeing. Note: soft water dissolves lead if supplied in lead pipes. It will cause lead poisoning. Soft water has no taste, hence not suitable for brewer. Soft water does not contain calcium, therefore not suitable for strong bones and teeth. Properties of water. Physical properties of water. Pure water is a colorless, odorless, tasteless liquid. Not that type of pure water we are drinking. That thing is not pure water. Pure water is a colorless, odorless, tasteless liquid. It freezes at 0 degrees centigrade and boils at 100 degrees centigrade. at a temperature of 760 millimeter mercury or 1 atmosphere or 10,132 or 101324 millimeter mercury Newton meters. Newton meter. Number 4. Number 3, water has a maximum density of 1 gram per dm cube at 40 degrees centigrade. Number 4, neutral to litmus paper. Chemical properties of water. Actions of water on metal. Water reacts with metals in many ways depending on the position of the metal in electrochemical series. For instance, metals like sodium, potassium, calcium react with cold water to give alkaline and hydrogen gas. Look at the equation below. Reaction with sodium and water to give us sodium hydroxide and hydrogen gas given out. Magnesium, zinc, and iron react with steam to liberate hydrogen and form oxide. The reaction between magnesium and steam gives us magnesium oxide and hydrogen gas given out. Iron reacts with water at red hot to give us the reaction between iron 3 and steam gives us iron 3 oxide and hydrogen gas. Other metals like copper, gold, silver, mercury do not react with water. Number 2, reaction with non-metals like chlorine. Water reacts with chlorine to form hydrogen chloride, that's hydrochloric acid, and oxochlorate 1 acid. Also, water reacts with carbon to give us water gas. The water gas is carbon monoxide and hydrogen gas. That is water gas. When you look at the equation, we have CO plus hydrogen is called water gas. Oxides of alkaline metals, that's number 4. Oxides of alkaline metals form hydroxide with water. When they react with water, they will form hydroxide. For instance, reaction of sodium oxide with water When you react sodium oxide with water, it will give you sodium hydroxide. Other examples: potassium hydroxide and potassium oxide and calcium oxide. Number 5. Water reacts with oxides of non-metal to produce acids. Example: SO2, SO3, NO2, CO2, P2O3, and P2O5. When they react with water, they will give us the corresponding acids. We move over to hydrolysis of water. Some compounds react with water and are split by water. This process is known as hydrolysis. Example: salts of weak acids and bases undergoes hydrolysis to give acid and alkaline solutions. Example: sodium tetraoxosulphate 6, when react with water or dissolve in water, it will give us sodium hydroxide and tetraoxosulphate 6 acid. We have other examples: sodium carbonate, ammonium carbonate, and aluminum nitrate. But that is not the IUPAC name. Please find out the IUPAC name of these compounds. Taste for water. When water is added to white anhydrous copper 2 tetraoxosulphate 6 powder. Anhydrous copper 2 tetraoxosulphate 6 powder is a substance that doesn't contain water. So when you add water, the powder turns blue. Equation for the reaction: the product will be copper 2 tetraoxosulphate 6, which contains five molecules of water. The product will be called blue hydrated salt. Hydrated means that it contains water of crystallization. It contains water of crystallization. Also, water turns blue anhydrous cobalt 3, cobalt 2 chloride, pink. Uses of water. 1. Water is foundation of everything. Without water, plants and animals cannot exist. A. Water is used at home for laundry, cooking, bathing, drinking, cleaning of household furniture, etc. B. Water serves as solvent in manufacturing industries. Example: distilled water is used in manufacturing of drugs and blood infusions in pharmaceutical companies. C. Water is used in washing and cleaning of machines. We move over to solution. What is solution? Solution is a uniformed or homogeneous mixture of two or more substances. That is formed when a solute dissolves in a solvent. A solute is a solid substance, while solvent is a liquid what? Substance. Solvent like water to give homogeneous mixture. Solute plus solvent gives solution. Types of solutions. 1. Solution of solid in a liquid. Solution of liquid in liquid. Solution of gas in liquid. Very soluble. Solution of solid in solid. Having finished our topic, although we still have some to look into underwater. So we move over to assignments. The assignment, number 1 assignment, explain the term hardness of water. Give the formula of one substance which causes permanent hardness. 2. Write equation which shows calcium hydroxide being used to remove temporary hardness from a sample of water containing calcium hydrogen trioxocarbonate 4. 3. Give the test for water. So students, here comes the end of the lesson. Please try as much as possible to read and do the assignments. Please stay safe and remain blessed in Jesus' name. Amen.